Hi, I'm Madhvi Bachu. I'm the product manager at Parkson Corporation for Lamella Gravity Settler. Today we will be talking about Lamella Gravity Settler. The agenda looks like this. First, I'll talk a little bit about clarification process, theory and design of Lamella Gravity Settler, and Parkson's experience and the recent developments we made and the benefits of those developments. And at the end, I'll open it up to the discussion and any questions you might have. Clarification process is nothing but removal of suspended particles that are heavier than water by gravitational settling. The time required for settling depends on several factors: size of the particle, shape of the particle, weight of the particle, and the viscosity of the liquid, which is also dependent on the temperature. There are three different types of particles in the water: dissolved particles, colloids, and suspended particles. The suspended particles usually range from large particles down to 10 micrometers, and colloidal particles range from 10 nanometers to 10 micrometers. And the dissolved molecules are dissolved in the water and they cannot be removed by physical chemical process. The colloidal particles are finer particles and they are usually negatively charged. So since they are negatively charged, they repel with each other, they always want to remain suspended in the water. They're very stable in the water, so you need to destabilize them first so that they can actually come together and can be removed as bigger particles from the suspension. There are three different stages of clarification. The first one is coagulation. This is where you will be destabilizing the particles by neutralizing the negatively charged particles. And the coagulation usually occurs very fast. It usually occurs within the first 30 seconds of the process, and you need a rapid mixer for the coagulation. And then the flocculation occurs. This is where the smaller particles come together and become bigger particles so that you can actually settle them faster. And the final step is the sedimentation, where you will be physically removing these bigger particles from the suspension. This is the table that actually shows settling rates by particle size at 50 degrees centigrade. You can actually see that the 10 mm gravel particle actually takes only 0.3 seconds to settle in 1 foot of water, while a microcolloidal particle takes 63 years to settle. So it's very important the particle to be bigger so that it can actually settle faster in the liquid. We can actually calculate the settling velocity theoretically using Stokes Law. Stokes Law says that the settling velocity is directly proportional to the square of the radius of the particle, and also the difference between the densities of the fluid and the particle, and inversely proportional to the viscosity of the liquid. But this law assumes that the particles are spherical and they are actually in the free settling zone. That means the water is not turbid. They are freely settling without colliding with any other particle around it. But that's a very ideal condition. It's not, in reality, the water will be very turbid and you'll have a lot of particles surrounded by it. So this law doesn't apply to high turbidity water, also called hindered settling. The most effective way to figure out the settling velocity is doing jar test in the laboratory. Theory of Lamella. Let's just consider this basin 1. The water will be entering the basin 1 at velocity VL, and it will be flowing along the length uniformly and exits the basin at the other end. And the particle will be settling at the velocity Vs. The trajectory will be shown as vector Vp. So this trajectory has to take the particle from the top of the basin to the bottom of the basin before it actually exits from the far end of the basin. So then you can actually assume that the particle has been removed from the basin. So if the particle starts from the top of the basin and travels through the height h at velocity Vs, it has to hit the bottom of the basin at the same time the liquid is in the basin. This can be shown by the formula. H by Vs equal to volume by Q. Volume is length times width times height. And simplifying this, settling velocity equal to Q by L times W, which is also Q by area. L times W is area. This is also Q by area is also called overflow rate or surface loading rate. What this is saying is the settling velocity should be greater than or equal to the surface loading rate or overflow rate, then all the particles in that basin will be removed at that point. And if you look at the first equation, the height actually gets cancelled out on either side of the equation. That also tells you that the settling efficiency is not dependent on the height of the basin, predominantly dependent on the height of the basin. This is the key point for the Lamella gravity settler, where the settling efficiency is not directly proportional or not dependent on the space restrictions. Let's consider basin 2, where the height of the basin is only half of the basin 1, and also the detention time is only half of the basin 1. Here, the velocity would be 2 times the basin 1, and also the slope of the trajectory slope will be only half of the basin 1, but the height is only half, so the particle has to travel only half the distance now, so the particle will still be removed. If you reduce the height of the basin by few inches and place such basins one on top of each other, that's called primitive shallow sedimentation. So in this example, you're actually looking at 10 compartments placed one on top of each other. So you can actually input 10 times the flow through the same basin without the plates, without the compartments here, I should say. But and also the detention time is only 1/10 of the basin without the compartments. But the separation efficiency would be the same, because now it's 10Q by 10A, because there are 10 compartments. You can actually use the area of all the plates. So it's still Q by A, so the separation efficiency would remain the same. But the problem with this configuration is, how do you remove the sludge? You either have to have bigger spacing between the compartments, so then you can actually install a mechanical scraper, but that seems very impractical. So what you can do is, you can actually incline the plates at a certain angle so that the sludge will be self-draining, and the sludge can be removed from the bottom of the basin. Here we are assuming an angle of 60 degrees just for the purpose of it's cosine 60 is 0.5. It's a very good multiplier to talk about. That's the only reason we are using angle as 60 degrees. Here total settling area would be number of plates times plate area times cosine 60. That would be your total area. Since cosine 60 is 0.5 here, in this example, you can actually input 5 times the flow through the basin with the plates compared to the basin without plates. Let's look at the Lamella flow path now. The water enters through the feed influent and enters the flash mix tank. This is where there will be a rapid mixer. You will be mixing the influent with any coagulants or coagulant aids for 30 seconds, and the water enters the flocculation tank. This is where you will have more retention time than a flash mix tank. You'll have a slow mixer. The flocculation time can be dependent on the application. If it's a surface water type of application, potable water type of application, then you would need up to 30 minutes sometimes. So the flocculation time purely depends on the application. If the water has less turbidity, then it would require more flocculation time, because you need more time for the smaller particles to come together and become bigger particles to settle down. And the water enters the feed box and goes down, and there will be feed slots at the side of each plate. The water enters the feed slots here. The clean water goes up, solids slide down to the hopper at the bottom, and the water enters through these discharge flumes. We actually have submerged orifice holes here. I'll talk about them in a minute. And the water enters through this overflow box and down to the effluent tank. And the sludge from the sludge hopper usually goes to a filter press for further treatment. The plates are inclined at 55 degrees angle to promote solids movement. Sizing is based on total projected area, which is number of plates times plate area times cosine 55. Cosine 55 is 0.57, so at 55 degree angle, about 57% of the total plate area is calculated as projected horizontal surface area. And usual plate spacing is 2 inches for high solids concentration. To accommodate high solids concentration, there are some applications where we can go with smaller plate spacing or larger plate spacing, but it's very application specific. We talked about submerged orifice holes. It's also called throttling hole here. These holes are designed such that you actually allow 2 to 4 inch pressure drop within the unit so that there will be uniform distribution of the flow. And also sludge re-entrainment is avoided as the sludge, the settling and thickening, everything occurs below the influent of each plate. These are the components of the Lamella gravity settler. These are the feed ducts. The submerged orifice holes that we talked about are right here. This is the feed box, and this is the overflow box, and that's the outlet. Parkson design has stiffeners. These stiffeners are there for structural integrity and also to optimize the length to width ratio and to also maintain the plate spacing. Parkson conducted some dye studies early in 1970s, comparing other inclined plate settlers just to see, how Parkson design is different from the other inclined plate settler design. This is the Parkson design with stiffeners. We introduce this dye through the plates, and these are the stiffeners, and you can actually see how the dye actually enters the plates. In the second picture, you can actually see that the dye has been applied onto the entire surface area of the plate. That means it actually distributes uniformly throughout the plate. The light that you're looking at in the middle is just a flash of a camera. So let's just look at the case one. What if there are no continuous stiffeners? Here's the no continuous stiffeners path. So in the middle picture, you can actually see that the water starts entering, the dye actually goes to the far end of the plate. And then in the third picture, it actually leaves a dead space in between, in the middle of the plate, which means that you are not utilizing the entire plate surface area. So what happens if there are no continuous stiffeners, inconsistent velocities? You won't be utilizing the entire plate area, and also there is clear short circuiting, and it will also affect the effluent quality. The case two would be, what if the velocities in the feed box are too high? Here you can see that in the middle picture, the dye actually started going towards the bottom of the plate. That means it will actually go directly into the sludge hopper. It will dilute the sludge in the hopper and also carry over some of the solids to the effluent, thus affecting the quality of the effluent. So the original Lamella gravity settler, Parkson owns Lamella registered trademark. We are the developers and world leaders of the inclined plate settlers. We have this product since 1971. We have 41 years of experience with this product, and we have more than 4,800 installations worldwide. We also have experience with every municipal and industrial application where suspended solids is an issue. We have customers like DuPont and Dow Chemical where they have very unique applications. We have very customized specification for them. And our largest plate pack installation is in Cincinnati, Ohio. It's a 175 MGD plant for us, water treatment plant. And I believe we have a biggest and largest package units, inclined plate settlers at Canadian Natural Resources Limited. There are 3 types of Lamella models available. The first one is called Lamella gravity settler. It's a hopper bottom unit. This is our standard type of model. It's delivered fully assembled for the smaller models, and for the bigger models, we will be shipping the flash mix, flock, and hopper separately, but the plates will be installed within the top portion of the unit. Low installation costs compared to the conventional clarification. It only requires 2 men with crane. 2 to 4 hours for smaller units. For bigger units with assembly and installation, it probably would take 6 to 8 hours. And our models range from 75 square foot to 3,900 square foot. And the second model is LGST, which is called Lamella Gravity Settler or Thickener. This has a thickening tank underneath and has a rake bottom inside, which slowly moves and thickens the sludge. We usually use this model for high turbidity type of applications, high total suspended solids in the feed. This will actually generate more concentrated sludge compared to the LGS, the hopper bottom unit, 3 to 5 times. It has high sludge holding capacity, and the model ranges from 360 to 3,915 square foot. And the third type is plate packs in concrete basins. We usually use this model for larger flows or municipal type of applications. They're installed in concrete tanks. You usually need a scraper or suction type of device to remove the sludge underneath the plate packs. And they are shipped fully assembled, and it requires 8 to 10 hours to install. And there we have plates which are UL approved and NSF certified. As I mentioned before, there will be applications where you would require more flocculation time. So Parkson also supplies customized flocculation tanks with 10 to 20 minutes or even 30 minutes detention time. This example you're looking at is for a surface water type of application. These are the typical municipal installations. I just wanted to give you a picture of what we have experienced in the past with municipal applications. We have our largest is in Cincinnati, Ohio. We have a couple of installations of 50 MGD in Chicago and then in Reno, Nevada. And we have served every industry out there. We are in metal finishing, oil and gas, petrochemical, chemical, pharmaceutical. We have served every industry where they're using water for processed water, wastewater. We are there. We also have very good experience with highly corrosive industrial applications like phosphoric acid, brine clarification. Parkson actually has done a number of lab tests and pilot tests with these type of applications, and we have experience with different material of construction that we have been using over the last 41 years. We are actually very proud to have good customers like Ford and General Motors. We have 30 installations in each of these plants throughout the United States. And DuPont and Dow Chemical, they actually have very customized spec. It's a very unique application. We are very proud to have such a customer base. So what's new in Lamella world? Last 41 years, we have been using a design, actually industry has been using a design where it's called 80-20 design. So usually the inclined plate settler specification calls for 80-20 design, which means you can only use 80% of the plate area. The area around the feed slot region cannot be used. So that's why it's only 80% plate area that can be used. So what Parkson actually did is we actually looked at the design and we wanted to provide a solution to the customer that they don't have to change any configuration of the unit or any footprint of the unit, but still give some benefit to the customer. So what we did is, if you look at the original Lamella gravity settler, this is where the feed slots are. So the water comes in through this feed box and enters these feed slots, goes up, solids slide down. So during this process, when the solids are sliding down, the water is entering through the feed slots, you are creating a turbulent zone right around this area. So that area cannot be used for designing purposes. You cannot say that that's a clarification area that you can use. So you are pretty much losing 20% area around that region. Just to give you a closer look, this is how feed slots look like. These are plates in a concrete tank. The water goes in through these feed slots, solids sliding down. You're creating a turbulent zone right around the feed slot region. Another closer look. This is how a 80-20 design would look like. Water goes in, solids sliding down. You're creating a turbulent region around that area. So what did we do with EcoFlow? With EcoFlow, all we did is we moved the feed slots to the bottom of the plate. So now the water enters through the feed slots, but you are minimizing the turbulence around that region because the solids will be sliding down the plates and the water will be getting into the feed slots from here. So you're creating two different regimes for feed and the solids. Now I want to show you a video which will explain this phenomena better.
It's an icon of the wastewater industry. Parkson's Lamella Gravity Settler, a solid liquid separation technology, has been serving municipalities since 1971 with over 4,000 installations worldwide. Parkson has also sold the Lamella to many different industries, such as metal finishing, power generation, chemical, petrochemical, mining, steel, pulp and paper, as well as many others. Parkson is now launching a new generation of this original plate settler. Introducing the Lamella EcoFlow. The most significant aspect of a gravity settler's design is its available settling area. The effective gravity settling area of the inclined plate design equals each plate's area projected on a horizontal surface. The original Lamella could only use 80% of the total plate surface area. This is because the path of the influent flow collided with the solids moving down the plate, causing a zone of turbulence that cannot be used for settling. This 80-20 split is the current industry standard when sizing a plate settler. To overcome this phenomenon and achieve 100% use of the plate area, the flow at the feed slots needs to be redirected away from the solid settling path. In order to improve the design and allow for full utilization of the plate settling area, the feed slot location was mirror imaged to be on the bottom of the plate instead of the top. This minimized the disturbance caused to settling solids, allowing for the use of 100% of the clarification area available. Parkson performed a full-scale pilot test to validate the design and produce a comparison of the two models. This is the original 80-20 design. Here the turbulence is evident from the influent mixing with the solids traveling down the plate. And here is the video of the innovative EcoFlow design. Feed enters at the sides of the plates. Solids slide down the plates without disturbance and drop into the sludge hopper. Sludge re-entrainment is avoided by segregating the feed and sludge, permitting the existence of two laminar flows.
EcoFlow is the first improvement in inclined plate settlers in over 40 years. What it means to existing customers is that, number one, for a given size unit, they can get 25% more capacity. Or, in fact, if they run at the same loading rates, they can actually get an improved effluent quality, which is important with regulations the way they are today. Finally, because of the hydraulics of the equipment, they're able to get a more dense sludge concentration, which means they have less waste that has to be reprocessed.
So we did a 6-month pilot study on this, and we actually installed an underwater camera right around the feed slot area and compared 80-20 design and EcoFlow. So because now that we are gaining 20% more area on each plate, you can actually treat 25% more flow within the same basin. All you have to do is just change the 80-20 design plates to EcoFlow plates, and now you're gaining more flow. What this means to new units is, now before probably we are quoting 1135 square foot unit for a particular project. Now you don't have to go with 1135 square foot unit. All you have to go with probably with 860 square foot unit. So now you will have some cost savings and footprint savings too. So there is no zone of interference between feed, effluent, and solids. What we also observed during the pilot test is there is enhanced sludge thickening and also high quality of effluent. This actually is another indicator that the influent is not disturbing the solids, because previously with 80-20 design you might be carrying over some of these solids to the effluent. Now since you are not really disturbing the solids sliding down, you might be actually seeing better effluent quality with EcoFlow. And now we are using 100% plate area, which means 25% more capacity. And nothing changed within the unit except for the feed port location. So for retrofits, it's as easy as just changing the plates. You don't have to change the entire unit now. Parkson has a field service team who can actually come in and can perform the entire scope of supply for our customers, but they can also supervise the operators if needed, the contractors on site, and also train the operators at the end. Parkson Fort Lauderdale facility has a research lab which has experienced lab scientists who has tons of experience. They have been doing these tests since last 41 years. We have done a number of lab tests and pilot studies on different kind of applications. We also have pilot units available, especially EcoFlow plate settlers are available if anyone wants to do on-site testing for their particular application. Another option available is integrated flash flock design. We pretty much eliminated the structural steel right underneath the flash and flock and attached the flash and flock to the Lamella unit. We have several different models available for this particular design. This is most useful where there are space restrictions. The another option available is FRP unit. This is only being offered for highly corrosive type of applications like brine clarification. We limited this design up to 1135 square foot unit because it's a square unit, and FRP, it's going to be structurally challenging if we want to manufacture units bigger than 1135 square foot unit. In summary, it's a competitive product. It's a patent pending. Product, and then also better performing compared to 80-20 design. 25% more capacity means, depending on the model, you can actually have savings from 10 to 30%, and better effluent quality, thicker sludge. And if you have filters downstream, and if you're getting better effluent quality out of your clarifier, you'll be using less chemicals. And it's an original inclined plate settler from Parkson, and we have 41 years of industrial experience, including highly corrosive applications. Thank you.
Okay. From a maintenance point of view, what are the requirements of the Lamella gravity settler?
There are not too many maintenance requirements for Lamella gravity settler. The most common type is periodical cleaning of the plates. It's depending on the application. For portable water type of application, probably the operators may have to clean the plates twice a year. For some applications, for some industrial applications where scale buildup is more common, you may have to clean it up once a week. All you have to do is hose down the plates with water, not using high pressure water, because that can actually break the plates.
What is Parkson's experience with primary and secondary treatment in municipal wastewater treatment plants?
How do you measure the sludge level in the hopper?
There are several different types of ultrasonic level sensors available in the market for sludge level measurements, but after a while they are not reliable. The best way to measure the sludge level in the hopper is for the operator to use the sample valves that are installed onto the side of the hopper, and over the time just measuring the sludge level in the hopper, testing where the sludge level is in the hopper will actually tell them, how much sludge is building up in the hopper, and with the help of controls or timers, they can actually remove the sludge continuously or periodically.
During the installation process, can two people lift a stack of plates?
The plate packs are the plate packs comes with 3 to 5 plates in one stack. So each plate weighs 20 pounds. So 2 people can actually lift the largest plate pack.